Hi, and welcome to our math. Today I'm doing a series of videos on rational equations and their graphs. For this first one, this is a really basic introduction, and I want to discuss some of the vocabulary that goes along with a rational function and its graph. So it says, find the domain of the following function and describe the behavior near any excluded x values. So if we look at this, we have learned in the past that x plus 2 cannot equal 0, so x cannot equal negative 2. This is my excluded value. So f of x is defined for any value except x equals negative 2. So our domain is negative infinity to negative 2 joined with negative 2 to positive infinity. All right, so what I want to do is I want to investigate. Let's look at what happens near x equals negative 2 from the left. And from the left, it means we're coming from the negative numbers, and the right. And so when I talk about the right, I mean we're coming from the positive numbers. This is a calculator-heavy example, so you might want to pause the video a lot, have your calculator out. I've done all the calculations, so I'm going to go through this pretty quickly, but having a calculator is imperative. This is not something you ever want to do by hand. So if we look at this, and we have x and f of x, and I look at these values, I'm wanting to look at what it looks like coming from the left. So I'm going to start at negative 3, and I'm going to go to negative 2.5, and then I'm going to, actually, let's start even before that. Let's look at negative 5, then negative 4, then negative 3, then negative 2.5, then negative 2.1, then negative 2.01, and negative 2.001. And from there, we'll see if we want to go further. If we put negative 5 into this equation, so 15 times negative 5 divided by negative 5 plus 3, we get 25. If we put negative 4 in, we get 30. If we put in negative 3, we get 45. If we put in 2.5, we get 75. If we put in negative 2.1, we get 315. This is where the numbers start to get fun. If we put in negative 2.01, we get 3,015. If we put in negative 2.001, we get 30,015. I often have students tell me if we put 0 in the denominator of a fraction, it's just equal to 0. But as we get closer and closer to this negative 2, we are getting closer and closer to positive infinity. If you look at these numbers, they are exploding up. Let's look at it from the other side. Let's do this again. Let's play the game. Let's look at x and f of x. We will start at 1, then go to 0, then we'll go to negative 1, then negative 1.5, then negative 1.9, then negative 1.99, and negative 1.999, and we'll see if we want to go further than that. If we start at 1, we are at 7.5. So we put 1 into here, we have 15 over 3 That doesn't sound right. I wonder if I put the wrong equation into my calculator. Dun, dun, dun. 15 over 3 should be 5. And this is 0. And -1 is -15. This one's correct. All right. Phew. All right. We're back on track again. And then if we put in 1.5, we get -45. And if we put in 1.9, we get -285. And if we put in 1.99, we get -2985, then -29985. And this time as we head towards -2, we're getting to negative infinity, which is kind of insanity, right? These numbers are getting really big, really fast. So, if we want to come up with a conclusion here, for our first one, as x approaches -2 from the left, and the way we're going to write that is we're going to say x approaches -2 from the left. That's what that little negative means. F of x approaches positive infinity. For this one, we're going to say as x approaches -2 from the right, so x approaches -2 from positive numbers from the right, f of x approaches negative infinity. So we have this barrier that we're obviously not touching at x equals -2. We actually have another barrier at 15 that we're not going to touch. You can watch other videos and I will give lots of details about this barrier. And we can see at -5, we were at 25. At -4, we were at 30. At -3, we were at 45. And we were heading towards positive infinity here. And over on this side, we actually hit the point 0, 0. And at 1, we were at 5. We were heading this way. At -1, we were at -15. At -1.5, we were at -45 already, which is already off the graph. And this is kind of a basic sketch of what our graph looks like. So some notes. The line x equals a, that's this line right here, x equaling -2, is a vertical asymptote. Asymptote is one of my favorite math words, of a graph. And it happens when f of x approaches positive infinity, or f of x approaches negative infinity, as x approaches a from the left or right. Now this other line up here, this y equals 15, this is called a horizontal asymptote. So that's our second note. The line y equals b is a horizontal asymptote of the graph, f, when f of x approaches b as x approaches positive infinity, or x approaches negative infinity. Identify the asymptotes from your example. So the vertical asymptote is x equals -2, and the horizontal asymptote is y equals 15. All right, there you go. A basic introduction to what an asymptote is, and kind of seeing with the numbers that when you divide by 0, it really does go to infinity. I hope you enjoyed this video. Please subscribe to my YouTube channel, and I'll see you on the next video. Thanks.